Okay, Georgie, let's see if this will work. Now, it says the graph below shows the motion of an object. So when you look at that graph, it says that the velocity to the north is negative, and then the time goes from 0 to 50 seconds. So they want you to answer some questions. So at what point or points in time is the object moving southward? So southward has to be when it has a positive velocity. So here it's having a less negative velocity, so it must be headed to the south. It's changed directions. Okay. Here it is not at 0, it's at a southward velocity, so it's definitely heading southward there. It's going from a positive to a negative, so it's slowing down, and then it has no speed right here. So let me go back and make sure I'm not telling you an untruth here. From 20 to 30, it's becoming less negative. The slope is positive, so it's headed in the opposite direction of this one here. Okay? All right, so B says find the maximum speed. So all you have to do is look on the graph and read that. Find the average acceleration from 16 to 32 seconds. Well, here is 20, 18, 16. It's not accelerating at all from 16 to 20. From 20 to 27, it's headed in the opposite direction. It's getting less negative velocity, so you could take the slope of the line and find the acceleration. There is no acceleration here. And then we're done, because it only wants to go to 32 seconds. Find the acceleration at t is equal to 4. So t is equal to 4 would be right over here. So the speed is increasing in the negative direction. Find the acceleration at t is equal to 26. Well, that's 27 right there. So 26 seconds is right here. So since this is a straight line, the slope is constant. So anywhere there, taking the slope of that straight line will give you the acceleration at 26 seconds. And when is the acceleration 0? When the speed is constant here, here, and here, the acceleration is 0. The speed of the object is decreasing at what points in time? Okay, so remember it's a speed, not a vector quantity, but a speed. So find out when that magnitude is getting smaller and smaller, and that would be the speed. And that should take you through there. Now, number 14 says that you need to find the displacements. So again, it's the area under the curve because it's a velocity versus time graph, so find your areas under the curve. And then it wants to know, determine the distance traveled by the object from 0 to 50 seconds. So get all your areas under the curve. Don't pay attention to positive or negative since you only want the distance, and add them up. Okay? All right, then number 15 says a skateboarder starts from rest atop a slope that is 20 meters long and accelerates uniformly 2.6 meters per second squared down the slope. All right, so I'm probably going to have to go to a clean sheet of paper. Let's see if I can write on this thing first. All right, so if my pen will work this time. All right, so we're going to say that, oh, stop that. Part A. What is the position of the skateboarder? D is equal to 1/2 AT squared plus BIT. Starts from rest, so I can get rid of that. So D is going to be equal to 1/2. The acceleration is 2.6. And I'm going to call that a positive acceleration because I'm going to say down the slope is positive. It's going to go on for 3 seconds. So you can find that distance and say the direction is down the board or down the ramp or positive or however you want to describe it. So that will give you the displacement because we'll have a magnitude in meters and a direction. Then it wants to know what is the speed of the skateboarder at that point. So VF equals VI plus AT. Starts from rest. A is 2.6, and it's positive because we said that was down the ramp, and down the ramp was positive for us, and it lasts for 3 seconds. So you can find the final speed at the 3 seconds. How much time overall is needed to go down the slope? Well, if you have D is equal to 1/2 AT squared plus VIT, and that's 0. You know this is a 20-meter long ramp. A is, in fact, you probably should rearrange this first for T. So when you do that, you'll have 2D over A is equal to T squared, but you want T, so take the square root of that, and then just plug your numbers in and solve it. Shouldn't be a big deal, okay? I'm going to erase all of this so you can pause it and look at it if you need to. All right, there we go. 16 says the maximum deceleration rate of a car is about 10 meters per second squared. Determine the distance required to stop your car when you're initially moving at 30 meters per second. Okay, so we're looking for distance. And we can say that VF squared minus VI squared over 2A would give us D. VF is going to be our 0. VI is our 30. And A is 2 times a negative 10, it says, because it's decelerating. So we're going to call that negative. So you could solve for that equation, and solve for that value. Where did that equation come from? VF squared equals VI squared plus 2AD. And I just solved it for D. Again, you can stop this, pause it, I'm fixing to erase, and move on. Alright, number 17 says you're investigating an accident scene in which several cars wrecked in order to avoid a car skidding to a stop. The skid marks are 65 meters long. Skidding car has a deceleration rate of that. How far was this car, how fast was it going? So again, okay, it skids to a stop, so VF is going to be 0. So you're going to have VI squared, negative VI squared is equal to 2AD. But since your A is negative, that negative can go away. And so you can solve for your VI by doing that math. Okay, pause if you need to look. Alright, 18 says an object traveling on a horizontal surface with an initial velocity of 12 meters per second, so it's headed that way at 12 meters per second, experiences acceleration, so I'm going to call that a negative 3 meters per second squared, is my A. This is my VI. Calculate the magnitude of the object's displacement at the values of 0, 4, and 8 seconds. Alright, so the magnitude of the object's displacement, D is equal to 1/2 AT squared plus VIT would work. And you'll have to pay attention to your positive or negative here because that'll be your displacement. And then it wants to know the speeds. Well, VF is equal to VI plus AT. And when you get your answers, you won't care whether they're positive or negative because it wants the speed. And then you'll need to talk about the motion. It went to the right, slowed down, and went back to the left. Whatever it does, you need to be able to describe that. So hopefully this will help you get there. Because I'm not going to work it for you. I want you to think about what they're asking you to do. Alright, so let's see. Where's my little... Alright, I'm going to go back to your original assignment and see if I can get to page 2. Not so good. Alright, let's see what happens here. So 19 says determine the displacement of a plane traveling northward that is uniformly accelerated from 66 to 88 in 12 seconds. So you know your T. You know your VI, you know your VF, and they want you to find the acceleration. Well, you have VF equals VI plus AT. You know this, and you know this, so rearrange and solve for A. So A is going to be VF minus VI over T, okay? Repeat the calculation for the same plane slowing down from 88 to 66 in 12 seconds and show that the result is the same, so that's not any big deal. You can easily do that. Alright, let's find my little X. Okay, 20 says a moving car decelerates for 5 seconds, comes to a complete stop. 75 meters are traveled in the process. Find the initial speed and the rate of deceleration. Okay, piece of cake. So we know D. We know T. And we know VF. Alright, so we have D equals 1/2 AT squared plus VIT. But that one's kind of stinky because we don't know the A and we don't know the VI, so not a good choice. So let's see what we could do with, could we do anything with VF equals VI plus AT? Well, we don't know A and we don't know VI, so again, not a good choice. Alright, so let's see, what do we want to do? Well, I know that D over T is equal to average speed, so 75 meters over 5 seconds is equal to my average speed. I think that's 15. And then we know VF plus VI over 2 will equal average speed. We know this is 0. We know this value. We know 2, and we know V. We're looking for VI, so that should be no big deal. You can get that. And then we want the rate of deceleration, so we're looking for A. So if we have VF equals VI plus AT, now we know this is 0. This is going to be 30, I believe, and this is our 5 seconds, so we can get our A. And it better come out negative. Okay? All right, let's see what this one says. Okay, 21 is one of the AP problems, he said. Let's take a look. The driver of a van times the light. Let me see how long I've been talking, because I don't want these to get too long. Okay, we got about 5 more minutes. All right. So it says the driver of a van times the light, passes through the intersection, constant speed of 15 meters per second, so that's his average speed. Okay, just as the light turns green, at the same time a car in the adjacent lane accelerates from rest, and so car number 2 has an acceleration of 3 meters per second squared. So what distance must the car travel in order to catch up the van? Okay. And what is the speed of the car as it passes the van? So the thing that they're going to have in common is going to be the time for car 2 has to equal the time for car 1. All right. So I'm going to have to stop and think about this for a minute, but I'll come back and do some more recording. All right? So I'm going to pause it, and then I'll be back. Okay, George, so I looked at number 21. So what I said was they have to have common times. All right? So I said, well, the time of car 2 has to equal the time of the van, so let's call that the van. So this one's doing an acceleration, so it's going to have D is equal to 1/2 AT squared plus VIT, and that's going to be 0. We know this acceleration, and we know that, what else do we know? Alright, hang on. Alright, so let me go back and see if I can work this now. Alright, so, oh, I need a pen. Hang on, dude, gotta get a pen. There we go. Alright, so their times are going to be even, but the distances they travel will also be even. So the one that is accelerating, because I got to catch each other, so the one that is accelerating has this equation right here to represent his motion. The one that's moving at a constant speed is just going to be average speed equals distance over time, or the distance for the van is equal to the average speed of the van times the time. So I'm going to set the distance of the van equal to the distance of the car. So I'm going to solve for t. So I'm going to have him moving at a constant speed of 15 meters per second times time. And then this guy's going to be 1/2. A is the 3 they talked about. And VI was 0, so I got rid of that. So there's a t here and a t here. I'm going to cancel them. So now I'm left with 15 meters per second. Half of 3 is 1.5. 1.5 meters per second squared will give me t. So t is going to be 10 seconds. And then you should be able to go back and get your final speed of the car by saying VF equals VI plus AT. So that's how I did 21. Alright, so pause if you need to, because I'm fixing to erase it. Okay, 22 says highway safety engineers design soft barriers so that cars hitting them will slow down at a safe rate. A person wearing a safety belt can withstand a deceleration of that much right there. How thick should the barriers be to safely stop a car that hits the barrier at 110 kilometers an hour and then slows to a stop as it crashes through and destroys the barrier? So they're looking for the thickness of the barrier, and so in other words, they want to know what is that right there. If this initial speed is the 110, which we cannot leave in kilometers per hour, so we'll change that here in a minute, and this final speed is 0. And the acceleration is a negative 300 meters per second squared. So they really are just asking what's that distance right there. Okay, so if I take 110 kilometers per hour, that's 110 times 1,000. Now I've got it in meters per hour, and 1 hour is 3,600 seconds, so 30.56 meters per second. 30.56 meters per second is the initial speed. You know the final is 0. You know the A and the D. So that looks like a really good equation right there. Solve for D and then get your, rearrange this for D and then put your numbers in and get your answer. Alright, again I'm going to get rid of that. Okay, the driver, you know what, I'm going to probably have to stop this one and make a new tape. Let's see. Yeah, I'm going to stop right there.